Good day, Algebra. We are wrapping up Unit 2 with PO15 Part 1. You were given this yesterday knowing it'd be homework due for tomorrow. So hopefully you got a chance last night to at least work through the rules for review, right? This first one is all from CO10. You've done that. Then we go to CO11. You've done that. CO12. You've done that. So if you did that, then the homework load tonight will not be as heavy. If you didn't, then it's going to be a little bit more. But this is basically right here the entirety of Unit 2. Okay. Do you know the 5 rules that we've talked about for exponent expressions? This is a key point, as are all the other rules, right? Put it on a help sheet. This combined with, do you know what a coefficient is? Do you know what a base is? That will determine your success. So let's just run through them here. Multiplying by the same base, back from CO10. What happens with the coefficient? Actually, I'm going to write the CO10 over here. What happens with the coefficient? What happens with the exponent? What happens with the base? Tristan. Multiply. Added. Base stays the same. Okay. Now, one thing kids in 8th grade ask is, how do you know which rule to use when? That's a valid question, right? How do you know what rule to use when? So what does a multiplying by the same base look like? What does that type of expression look like when you're multiplying by the same base? Yeah. You're going to see a multiplication symbol there, right? If you've got, folks, shh, quiet. 3n squared times 4n to the 5th, you see that multiplication symbol. You see that you are multiplying, right? And so that's going to clue you into multiplying by the same base. Dividing by the same base. What do we got? What are the rules? Andrea? It's the 3 S's, yeah. Coefficients are simplified, exponents are subtracted, and the base stays the same. Okay, this would be from CO11. Simplified, subtracted, and stays the same. What are you looking for that's going to tell you you're going to be dividing by the same base? What's your expression going to look like, Caitlin? You have a fraction, right? Because fraction meaning division is going to be something like 25n to the 10th divided by 5n to the 4th, something like that. It'll be written in fraction form. Okay. 0 exponents, CO12. This one's kind of obvious. If you have a power of 0, you know that you're going to be using the 0 exponent rule. And the coefficient, Andrea, stays the same. This is the one where the role of the coefficient and the base kind of flip-flop, right? Usually the coefficients change and the base stays the same, but in this one, the coefficient, because it's not affected by that power, it stays the same. The exponent is a 0, right? By definition. And what happens to the base? Everybody? Yes, and only the base becomes a 1. Only the base becomes a 1. That coefficient does not change. Negative exponents. This is how are you going to know you're dealing with a negative power? Well, if you have one, right? 4x to the negative 10th. Okay? This would be CO13 here. And what happens to the coefficient? Paul? Stays put. Doesn't move. Okay? Stays put. Exponents? Colin? Yes. Moves and becomes positive. If you want to expand on that because you don't know what moves means, like where does it move? It moves the other part of the fraction. Okay, if it's in the numerator, it goes down. If it's in the denominator, it goes up, right? But it does become positive. Tristan? Yes, the base follows the power. And does the base change? No. Yes, part 1 and part 2 are both due tomorrow, which is why I gave it to you yesterday and said, just so you know, this is going to be due on Friday. So if you wanted to get a jump on it, then you Could, but yes, part 1 and part 2 are both due tomorrow. And Con is due tonight. So if you didn't work ahead, it may be a fairly busy evening for you. But you have had 2 weeks for Con as well. So, but yeah, the base stays the same. The temptation is to make the base negative, especially if it's a number. That's not what happens. It just moves, but it does stay the same. And then distributing an exponent into parentheses. This is CO14. Obviously, what you're looking for here is parentheses. If you see them, that's going to be your hint that you're going to need to distribute. And notice I've got VC, variable coefficient. This should be CB, not VC. What was I thinking? CB, coefficient base and variable base. VC, what was I thinking of VC? Coefficient base, what happens to the coefficient base? Ethan. Takes on the power. The common mistake with this one is to multiply the coefficient and the exponent together. But again, remembering what's a coefficient, what's an exponent, they're not the same. And so they are treated differently. Exponents are multiplied together. Coefficient just gets the power. And then variable base, Andrea, stays the same. Colin, shh. Okay, stays the same. Cool.
Is it CB?
It should be. It should be coefficient base. I don't know why I was thinking VC. Verbal commitment, maybe. I don't know. Vacuum cleaner.
Like VC in 2K.
What does that mean?
It's like currency in 2K.
There you go. I can't even repronounce what you just said, but yeah, it could be that.
NBA 2.
Yeah.
22 or 24.
Why would it be NBA 2K? There's VC is what we're talking about. Oh, virtual currency. There you go. That's me. So V-Bucks would be VB, not VC. So if you know these things, you will be just fine for the test. Okay. If you don't know these things, the test will be a horrific experience for you. But hopefully that won't be anyone in here, right? So what PO15 does is it kind of combines all those rules together. Okay. For the most part, working up to this point, we just went rule by rule. Occasionally, you had multiple things go on here, but now in every single one, you've got multiple things happening. Let's look at the first one. X squared times x to the 9th over x to the 8th. What are the two rules here that are going to need to be used? Voltinsky. Multiplying by the same base and dividing by the same base, right? And you see that because you've got the multiplication symbol, right? And you've also got the fraction. The good news is that there really isn't an order you have to do these in, okay? If you wanted to divide by the same base first, there's a way to do it. If you want to multiply by the same base first, which is what I would recommend, there's a way to do that too, right? And so what do we do here? How do you want to go about this? Colin.
You want to simplify the numerator first?
Sure. How many x's do we have total up there in the numerator? X squared times x to the 9th, x to the 11th, 2 plus 9. And now that changes our expression to be x to the 11th over x to the 8th. Now we're dividing by the same base. Powers are subtracted. How many x's and where are they going to be? How many and where? Izzy?
It'll be x to the 3rd over 1.
Yes, x cubed in our numerator, because that's where we have more x's to start with. If you want to put the over 1, then you can, but you don't have to since it is over 1. But that's how you would do it. Okay, kind of multiple steps here. This next one, 5, a to the 4th, b to the negative 3rd, c to the negative 8th, all that to the negative 2nd power. What rules do you see here? Andrea? Because of the parentheses, you know we're going to have to distribute. And what else do you see? Anybody? Negative powers, right? Which means you have to move stuff around. Is it more efficient to start with the negative power moving stuff or the distribution into the parentheses? What's more efficient? Andrea?
Since the exponent outside of parentheses is a negative power, it's more efficient to first distribute it.
Yeah, in this case, it's more efficient to distribute first, because if you go through the effort of moving that b to the negative third and c to the negative eighth, when you distribute in the negative 2, it's going to change them negative again anyway. You have to move them back, right? A negative power, when you distribute, is going to change the sign of all the exponents you already have. So in this case, it's more efficient to distribute first, 5 to the negative seconds, 8 to the negative eighth. Because now watch what happens. That b to the negative third becomes now b to the positive, not third, b to the positive sixth, because negative 3 times negative 2 is a positive 6. And that c to the negative eighth is now a c to the positive 16th. Again, because the sign changes, because you're multiplying a negative by a negative, right? So now what you end up moving are the negative powers, the 5 and the a, and so your final answer, b to the 6th, c to the 16th over 5 squared, a to the 8th, it's more efficient to distribute first. Okay? Would it be wrong if you move the negative powers first? No, you just have to move everything back again. So, but that's all right. Okay? Give me another one that you want to go over. From the remaining 6. Nick, what looks fun?
The n negative 6.
Yeah. Okay? What do you want to do here? What do you see? What rules do we have to work with here, Ethan? Distribution, parentheses. What else? Nathan? Negative powers. What else? Naveen? Dividing by the same base, right? 3 of them. Does it matter which one you start with? No, it does not, which is the beauty of this, right? So where do you want to go? What do you want to do first? Andrea. Okay, we can go ahead, and since it's negative, go just distribute that first, just to take care of any sign changes that might happen here. Negative 6 times a negative 2 is n to the positive 12th, and then n cubed, 3 times negative 2 is n to the negative 6th. Now what? Maddie. Paul. Sure. If we move this negative exponent up, we now have n to the 12th times n to the positive 6th in our numerator, right? Because that sign changes. We're not dividing by the same base anymore. Now we're actually multiplying by the same base because they're all in the same part of the fraction. And what do we get? N to the 18th. Yeah, good. Okay. If we hadn't gone that route, what else could we do from this step to simplify this? Eli. Right. We could go dividing by the same base rule, which is subtract the powers. 12 minus negative 6. What does it mean to subtract a negative? You're actually adding it. 12 minus negative 6 gives us positive 18 as an exponent anyway. Right? The beauty of this, doesn't really matter how you do it. Doesn't matter which order the rules are used in, as long as you use them correctly. Okay? It's like MapQuest, when it gives you 3 different routes, and you get to pick which one you want to do, right? You get to pick. Glorious thing. Nathan? Gladly. Question, Paul? Okay. Last one. What do we see? Do you see multiplying by the same base? Yes. Do you see dividing by the same base? Yes. Do you see parentheses? Yes. Do you see negative powers? Yes. Do you see a 0 power? We got the, what would that be? Not a trifecta, not a quad, a pentafecta. Not sure that's a word. All 5 of them here, right? My goodness. What do you want to do first? In this case, since you've got so much going on in the parentheses, I would highly recommend you simplify within the parentheses first before you distribute. The exception to that might be if the exponent's negative on the outside. But even then, with so much going on, distributing to all that stuff might get kind of crazy. So I'd recommend simplifying as much as you can first. Maddie, what do you want to do?
You can add the what is the word? Is it coefficients? Or no, it's the base. Okay, it's we can add the like n's and the x's together.
Yes, we can combine the n's and the x's because they are similar bases. If we have 9 n's in our numerator and 3 n's, n cubed in the denominator, what does that give us as an exponent overall? How many n's and where are they? Even though they're different fractions, remember with fractions you multiply straight across anyway, right? So even though they're part of different fractions, since we're multiplying, we can combine them in this step. Yeah.
It would give you n to the power 4 in the
N to the power of 6, right? 9 minus 3, 6 in the numerator, yes. So we're going to write this fraction. We're going to put that power of 5 out there. We've got n to the 6th up top because 9 n's minus 3 n's gives us n to the 6th. How can we combine the x's? We have x to the 7th in the denominator. We have x to the negative 3rd in the numerator. How are they going to all come together here? Maddie?
x to the 10th.
Where?
X to the 10th on the
Right. What's going to happen with these negative 3 here, it's going to move down, become positive, and so in our denominator now, we've got x to the 7th, that's there. X to the negative 3rd is moving down, giving us 3 more. Total, we have x to the 10th in the denominator. We could have also subtracted the powers, like we did with the n's. Negative 3 minus 7 would give us x to the negative 10th in the numerator, which would then move down to give us x to the positive 10th in the denominator. Okay, multiple ways to think about it. Just got to do it right. What else can we do to simplify this fraction, this monstrous exponent expression? So you have someone we haven't heard from yet today, perhaps? Any new voice? Heard from you.
You can change Z. Do you call it?
No, but go ahead. It's fine.
You can change Z from 0 to 1.
Right. Any base to the 0 power can usually just be eliminated because it's really not there anyway. Okay, thanks for telling me I've got no z's here. Fantastic, right? And so it's just gone. And this is a much simpler expression now than it started with, right? N to the 6th over x to the 10th, all being taken to the 5th. Now we can distribute only to 2 things, and we get n to the 30th, 6 times 5, over x to the 50th, 10 times 5. And that would be our final answer. Okay? So these do take some time. It's easy to get lost. It's easy to miss a step. It's easy to miss a sign. If you're someone who doesn't like to show work when you do the math, you might find yourself making some mistakes. Take the time. Other questions? The rest I'm going to have you do on your own for this page? Yeah?
On the test, it's not just but on the test, can we use scratch paper?
Scratch paper?
Yeah.
Yes.
But we use scratch paper and then we write the final answer.
Yes. That's okay. Yep. Yeah. So your homework is the rest of this page here, the 4 that we have not done. And then the second page, this is homework as well, the whole thing. You're asking for which one?
The second one.
This one? So kind of similar to the one we just did. What do you see here? You see dividing by the same base, and you see parentheses, right? So I recommend simplifying within the parentheses first. Take care of your coefficients. 2/6 gets simplified, right? Your exponents get subtracted. And then you're going to distribute in to what you've got left. I'm going to leave it there because I do want you to practice this on your own here, but that's the rule. Simplify coefficients, subtract the exponents, and then distribute in that 3 when you're done with that, right? Okay, homework for tomorrow. Practice test tomorrow. Test on Monday. Con due tonight. My goodness, that's how you math.